Hello. So I'm Matt Rhodes. I'm an application engineer at MathWorks, and I'm assuming most of you know MATLAB and Simulink. Maybe not as many know about Polyspace, the code verification software that we have. Seen the poster out on our booth with some C code on it. Check it out, come by, talk about it if you want. We've been coming into this conference since 2014. It's been fun. Last year, I did a talk on the evolution of code review that was fun to put together. I actually introduced then briefly what I'm about to talk to today in more depth. So we have actually, if you look at the scope of how static analysis is used, there are three main modes of using static analysis that are important for workflows. So while you're working on the code, obviously, is something we've done for a long time. And automation, CI pipelines, things like that, and also how you actually work with your team to figure out what to do about issues you find. So those are all things that I'll touch on, but I'm going to focus today actually on something that we introduced back in 2021 that kind of changed that first element for how you work with finding issues as you code, which is pretty cool. Short version, it's basically moving, in addition to the linting you get in most IDEs, it's moving the power of Polyspace directly into your IDE for most of the things that are most important to check as you go. So if you look at the landscape for how you integrate these tools, let's start at the end for a second, actually. So the end, after the CI pipeline, when you're done, everything's checked off and hunky-dory. We've always had the Polyspace code prover capability there for helping from the formal verification and making sure you're proving the absence of errors in your code. 2013, we added the bug finding capability. We've always had coding rules well, not always, but for a long time, we've had coding rule capabilities and other defect checking. And in 2019, we added the Polyspace access at the top there, the quality monitoring. And that's really important because it provides integration with your Jira workflows, Redmine for bug tracking and things like that. But it really changes the way you can collaborate with your team to figure these things out more effectively. And that's a really cool capability in of itself that has simplified how teams can use these tools. But I really want to focus on is this Polyspace as you code, which is a an IDE capability. So I'm going to show this to you, some screenshots from how it fits into VS Code. We also support Eclipse and Visual Studio and some other, you can do other custom integrations as well. We've got people using it in Emacs and Vim, for instance. And why is it important? So the normal lint capabilities you get, the what you see in your IDE is typically pretty simplistic, right? And so a lot of times people have relied on having the CI pipelines to get the full integrations of analysis, more in-depth things, especially code prover being able to prove the absence of runtime errors out of your CI pipeline. But a lot of the heavy lift that slows people down is trying to comply with coding rules, finding other simpler checks as you go. And so being able to have these checks on demand in your IDE, just take a moment. A few of these things here I'm sure resonate for you, whether it's on demand or just the fact that it's easiest or least expensive to deal with some of those. I don't know about you, but for me, I was like having the ability to see what's going wrong, what I need to fix while I remember the code, rather than later on, well, it's not exactly easy to remember what I did because it's come through a pipeline later on and I have to remember everything all over again. And additionally, you get to have the ability to develop better habits. You wait till a pipeline comes along or coming to a peer review for your team, the habits you would get from seeing how to fix things before you even check problems into your code aren't going to give you good habits to make your coding better, right? So being able to have those things reinforce what you need to do as you're writing your code while you're focusing on what you want to focus on, and have those things show you how to do it better are extremely helpful, right? So having that in VS Code or Eclipse or Visual Studio or your other IDE of choice is critical for a more effective, efficient use of static analysis in conjunction with the CI pipelines for full integrations, in conjunction with your team reviews and being able to track things through your Jira, Redmine, or whatever other tools you're using for tracking. It's no secret that doing these things while coding is going to cost less as well, right? The first study that was out for talking about reducing costs was Bowman Basili, and I forget exactly what year it was, late 80s, early 90s. A more up-to-date version from NIST. That's been pretty constant. So to us, the importance of getting these tools, the better version of static analysis available to you in your IDEs has been important for a long time. And just to give you an idea of the kinds of things that you can check, if you're already familiar with Bug Finder, this represents, the Polyspace code represents about 80% of what you can check with Bug Finder at the single translation unit level. Right? And so, lots of coding rules, all kinds of defect checks and types, and metrics as well. So if cyclomatic complexity, which is in your NPR, for instance, other metrics, and if you're doing code prover, you have access to, outside of this later on, by the way, you have access to stack analysis. So I've seen a few things about that worth pointing out today. It's also easy to coordinate across your team. You can actually configure these things. We have easy file-based and graphical selection of what things you turn off and on. So you're not looking at everything. You look at what's important to you based upon your team's standards, right? Easy to tune and share that tuning with the rest of your team. Easy to check it into your repository, so it's easily accessed as you go. So this is a shot of VS Code, and on the left, you don't recognize that panel. That's because that's the Polyspace code integration, and you see there's a quality monitoring panel up there that you can choose which files out of your repository matter to you versus the rest of your team, what you're working on. And every time you save, it'll update findings for you as you're going. You get to see details about what's going on, trace backs when relevant. You can actually open that up a little bit to see more. You get to see justifications in line to be able to say, all right, this is something we're going to justify. I didn't picture it here, but there's actually more recently the ability to, if you have common justification. So for instance, if you're using the MISRA coding rules and you're complying with those MISRA C2012, they actually added a database of canned, known, acceptable reasons to justify coding rules. And so you can actually pull those in and have those at your fingertips when you're justifying based upon what it is you're trying to check. So rather than go the whole process of justifying and making sure it's approved by our team, there's some that are just make sense and you can use them, and they're much easier to automatically validate. Many of these coding rules are new to engineers writing code, and so being able to have the help right there, you can actually see over on the results details on the left, there's that little book icon that lets you click on to see that this help document, contextual to what you're working on, explaining it with rationale for why the rule is there, examples, so on and so forth. And again, this is available today out of the box with Eclipse, Visual Studio Code, and you can do other integrations as well. And I mentioned it's save on demand for analysis, or putting it into the quality monitoring panel is there, ad hoc analysis, pretty straightforward, easy to use, which is why it's great. And yeah, so if you want a demo of this, you want to see how it works, you want to see what's going on with it, you can come by the booth. And for those of you who wonder, like, wait a second, where was the MATLAB? There's no dependency on MATLAB licenses for this. So if you don't even use MATLAB or Simulink, well, you should, but that's not a story. You can use this on your handwritten code. There's no dependency there. The Polyspace you code is specifically for C and C++. The bug finder works on C and C++ as well. And Polyspace Code Prover, which formal methods tool, can really help for robustness testing. So I know some of you also go into the DO178 world. That's actually really important for reducing your robustness verification. That works on C, C++, and data. And if you do like your MATLAB, we do integrate with model-based design. So there are reasons to run Polyspace on your generated code. We can talk about those. And least of all, is showing compliance with the coding standard. I believe the NPR has a clause stating that generated code even needs to be verified the same way anyway. So there's that. And yes, we have a map for NPR 71 for not just Polyspace, but for all of our tools in MBD. And so you can go look at that. And rather than having to read that, here's a handy QR code. Or if you download the slides later, you can actually click on that link too. That QR code is clickable. So, any questions?
I have a question. Surprise, surprise. Sorry, is this on?
Okay. All right. Great. Thanks. And so I do mean this sincerely, although it may come across as snarky. I don't mean it that way. Do the MathWorks code generators produce code that is Polyspace clean? And I posted this before you got to the end where you talked about running the code generators on the MathWorks output. But a big issue with these is that they produce a lot of false positives. And so to the extent that the MathWorks code is not producing false positives, or more warnings that are requiring your attention, the better.
Yeah, so that's a good question. Simply put, the code generator does what you tell it to do. And so when you run your code generation process, if you tell it to turn on divide by zero checking, for instance, across all of your code generation, it'll do that. For this kind of software, although that sounds great, when you actually get down to running a tool like Code Prover on it, you're going to see that you're going to have a lot of places where that actually creates dead code because you're not going to have a divide by zero condition anyway, which affects your coverage, et cetera, et cetera. So it's actually not a good idea to do that. And so really that's just an example of the point being that you should be using these tools early in your process as soon as you can, not just Polyspace, but any verification you have to do, as soon as you can run it for however you're generating your system, implementing your system, whether it's code generation or writing it by hand, as soon as you can do the verification at the lower levels, the better off you'll be to avoid other problems, such as putting in dead code later on that's the pain to deal with, because now you go and turn that setting off, and then so it's not about generating clean code outright. It's about understanding what you're telling the code generation to do in the first place so that you get the right set of code out of that.
Got it. Okay, thanks. Alexandra?
Hi, I'm Alexandra. I am a 8th generation flight software lead for the Curiosity rover, so I inherited a lot of code that was not mine. And one of the challenges that we had recently when we were writing some new software that we're about to install on the rover is doing some static analysis and checking it and making sure that we didn't break anything. We inherited a lot of we're violating a lot of rules that were waived way back when. We don't have records of that because they were in a different system. Is there a way? I'm specifically thinking about your last slide where you have down at the bottom, there's all these violations, right? Is there a way that you can mark violations as not applicable, waive them, and then have the system remember it for next time so that it doesn't
yes.
tell you that, hey, you need to alphabetize things or whatever?
Yeah, there's a couple ways of doing that, and depending on where your code's coming from, how it's done, we can talk about that if you'd like it's so there you can do comments in the code. If you're generating code, you can annotate your models, and also in the pipelines for doing your verification, you can import previous justifications, comments, etc., forward to simplify things.
Okay.
So depending on where you're coming from, we should talk about what's better for your system.
That sounds great. Thank you.
And last question from online from Ting Chow. What page 9 shows, is it a VSC, Visual Studio Code plugin? No MATLAB dependency required, license or runtime?
Sorry.
Page 9, he's asking if it's a they're asking if it's a VSC plugin.
Page 9.
And then asking about MATLAB dependencies, either license or runtime.
Gotcha. So what you're seeing here in this slide and the variations here, that's all in VS Code. As you can see in the lower left, we have Eclipse and Visual Studio as well. There's no MATLAB dependency for any of the Polyspace tools whatsoever, unless you want to integrate with model-based design. That's the only place there's a dependency, and that's simply to be able to have, and that's kind of loose actually, because we have a way to let you export from the system using model-based design and code generation, and sending that analysis to a system that doesn't have any of that on it to do the Polyspace. So there's lots of different workflows and ways you can make it fit for what you need, but no MATLAB dependency there. And is that?
And just runtime dependencies, and I would imagine, yeah.
Right.
Okay.
Very good.
All right, let's thank Matt, everyone. Thank you.